Okay, so when we plugged -2 into the function, we got -7. And so let me see. Ashley, when you plug in 0, what do you get?
-1.
-1, do you guys agree?
Yeah.
Okay, that's correct. I'll show the work here just in case. 3 times -1 minus 1, so that is, 3 times 0 minus 1 is 0 minus 1, which is -1. So that's correct. And then, Mitchell, what did you get when you plugged in 1?
2.
So 3 times 1 minus 1, so that's 3 minus 1 is 2. That's correct. Okay, and Alex, how about 3? What's f of 3?
8.
Good. 3 times 3 is 9, minus 1. That's 9 minus 1 is 8. That's correct. And so now we realize that when we put in x equals -2, the value of the function is -7. So we can plot that as the y value. So this becomes the point -2, -7. This becomes the point 0, -1. This is the point 1, 2. And when x is 3, the y value is 8. And so now we can plot those points. -2 in the x direction, -7 in the y direction is there. So this is the x-axis and the y-axis. And then 0, -1 would be right there on the y-axis. And then 1, 2 would be there. And 3, 8 would be there. Okay. Now it may be tempting to draw the line through those 4 points since they're lined up so nicely, but we actually don't want to draw the line through those because that would be if we included all possible x values, but since our domain is only those 4 numbers, our graph is only 4 points. So this is a discrete graph because the domain was set at only -2, 0, 1, and 3. Okay, so that is all we can graph. We don't want to draw the line through those points. Any questions so far? Okay, so we'll go on to example 2. The difference between example 1 and example 2 is in example 1, the function was given in function notation, whereas for example 2, this one is not written as a function. We can still graph it, but we're going to have to do a little bit more algebra in order to find the missing y values. So one possible way to do that is to say, okay, I'm going to plug in -3 for x. I want to figure out what is the missing y value that goes with that. And so I can do that here. I can recopy this equation and replace x with -3. And then I need to solve for y. Okay, so -2 times -3 is 6. And then what would I do next to solve for y? Okay, Rachel. Okay, subtract 6 from both sides. Now I have 3y equals 6. And Famaz, then what is y?
2.
Good. Y equals 2. And so now we have the point -3, 2. So let's go ahead and draw our axes. There's our x-axis and our y-axis. So the point -3, 2 is here. Okay? So now go ahead and follow a similar process. If we plug in 0 for x, we want to find the y value. Plug in 3 for x, find the y. And plug in 6 for x to find the y. So go ahead and work in your groups to find the missing y values. Sabrina, what did you get when you plugged in 0 for x?
When I plugged in 0, I got 0, like x is 0 and y is 4.
Okay, so do you agree that y is 4 when x is 0? Okay, good. And Sam, how about when you plug in 3, what did you get for y?
-6. No, not -6. Wait, I did somewhere. It would be, yeah, it would be -6.
Negative 6, do you guys agree?
No, wait.
No?
Wait, would it be -2? Because it's -3.
So let's do the work. So if we plug in 3 for x, that would be -2 times 3 plus 3y equals 12. So we get -6 plus 3y equals 12. Add 6 to both sides. 3y equals 18. So Sam, what's y? Positive 6. Okay? And so let's plot those 2 points. We have 0, 4, and 3, 6. Okay? And let's see, Brandon, did you get an answer for 6?
6, I got 8.
Okay, do you guys agree? Okay, 6, 8. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6, 7, 8. Okay. Would anyone like to see the work for any of these four? For any of those points? Everybody got those? Okay, so again, we don't want to draw the line through those points. This domain only includes 4 x values, so we only have 4 y values to go with them, and our graph is just those 4 points. Any questions? Okay, for example, 3, this time there's no domain given. So that means x can really be anything that we can plug in. So when we graph it, we can choose what values we want to put in. And so we'll set up a table of x values. So we might want to try some negatives and some positives. So what if we try -3, -2, -1, 0, 1, and 2. So for the function, we'll put f of x here. And so I'll do the first one with you. So if we plug in -3, the work would look like this. I'd have 2 times, it says x squared, and so my x value is -3 squared minus 3. And then the answer we get, let's call that y, because we'll end up graphing that as our y coordinate. Okay? So what is -3 squared? Positive 9, right? Because negative times a negative is a positive, so we get positive 9 times 2, 18 minus 3 is 15. And so this becomes the point -3 for x, 15 for y. -3 for x, positive 15 for y. Is right there. Okay, so this middle column is where I'm doing the work, and then I put my answer in the third column, and then we could even call this a fourth column for the point x, y. Okay, so go ahead and try that for -2, -1, 0, 1, and 2. And before you plot them on your graph, check with your group members and see if they're all getting the same y values. And I'll come around and help you. Just put your hand up if you need a little bit of help getting any of those answers. So go ahead and work on the next 4 points and work with your group to do that. Okay, Jackson, did you get an answer for -2?
5.
Do you guys agree with -2, 5? So we'd have 2 times -2 squared minus 3, so that's 4 times 2 is 8 minus 3 is 5. So that is correct. -2, 5. Question, you guys? There you go. Thanks. Okay, and then Kaylee, what'd you get when you plugged in -1?
I got -1.
Good. -1, -1. I believe that's correct. Do you guys agree? Okay, and then Kate, how about 0? What did you get when you plugged in 0?
I got -3.
Good. -3. 0, -3. And Maya, how about when you plugged in 1? 1, -1. Okay. And then 2, Zulfi? 2, 5. Do you agree with that one? Okay. So now if we plot those points, we have -2, 5. -1, -1, which is down here. 0, -3, down here. 1, -1, and 2, 5. Okay? Now, in this case, remember, there is no domain given, so we assume that we can evaluate this function for all possible x values that we can plug in, and that creates... Okay, so to graph a function on your graphing calculator, I know many of you have never used a graphing calculator before, so I'm going to go through and show you the steps for this. And so first I need to kind of rearrange my window so I can have my graphing calculator showing at the same time. So let's see. Do that, and there we go. Okay, so now we can see the graphing calculator and our instructions at the same time. Okay, so for this problem, I'm asking to graph the function f of x equals -x squared plus 2x minus 1. Okay, so first of all, some of you have brand new calculators. Some of you have a calculator that somebody else used before you. First, let's start off by clearing everything that's on the screen. So when you turn it on, just press clear a couple times so that you have a blank screen. If you have a graph or something on your screen like that, you can get out of that by pressing second, which is there, and then quit, which is there. So second, quit, and then that puts you on your home screen. And again, you can press clear a few times to clear everything out so we have a blank screen. Okay, so raise your hand right now if you are not able to get to this blank screen. So as we go through each step, make sure you stop me if you're not where the rest of us are, so we can keep you caught up, because once you get behind it might be hard to catch up. Okay, so stop me and I'd be happy to help you through the process. All right, so now we're ready to type in this function. So the place where we graph functions is the y equals menu. So the y equals button is right up here. Everyone press that. And mine has a function there. I want to clear that out. Yours might be blank, or it might have some other stuff typed in there. If you have anything typed in that window, go ahead and press clear and clear all that out. So raise your hand if your screen doesn't look something like that right now. So y equals, and then clear. Okay. Anybody else? Just clear all that out. So we'll clear, clear. Okay, they're all cleared out. Okay, anybody else? That's exactly what it's supposed to look like. Okay. Now, some of you see these words up at the top, plot 1, plot 2, plot 3. Some of your calculators might have one of those darkened in like that. So see how it says plot 1 and it's blackened? If yours has that, we want to turn that off. So the way you turn that off is you go up to the plot and press enter, and that'll turn it off. Okay? So that's what we want. We want those words, plot 1, plot 2, and plot 3, we want those turned off because we're not using any plots today. And so make sure all three of those are turned off, which means they don't have a black box around them. Okay? So it should look just like that. Now I want to put my cursor at y1. That's where we're going to type our function. And I want to point out that there's a difference on the calculator between the negative sign, which is down here, okay, and the subtraction sign, which is right up here, okay? So for this expression it says negative x squared, so we're going to use the negative sign for that. Negative x, the x is right here. The button says x, t, theta, and n, but when we're in this graphing mode, we're only using the x, okay? So x, and then we want it to be x squared. So we can do that by pressing the x squared button. So now it says x squared, and then plus 2x minus 1. So make sure you are typing subtraction, not negative. Okay? So we can tell the difference on the screen between the negative sign and the subtraction sign. The negative sign is a little bit shorter and a little bit higher than the subtraction sign. Okay? See how it's longer than that one is? So that should be a negative, that should be subtraction. Okay? So raise your hand if you need help typing that equation in exactly as I have it there. Everybody's with me?
Wait, how do you get out of this one? Just go down. Okay, so I'll type negative x squared plus 2x minus 1. Okay, good.
All right. So now we're ready to see our first graph. So you can press the graph button, and it graphs the function. Your graph might look exactly like mine, or it might look a little bit different. If it looks different, it's probably, there could be two things. Either you didn't type the function in correctly, or it's just a different viewing window. And so this is, everyone do this with me right now. If we press the zoom button right in the middle, zoom, option 6 is zoom standard. What that does, if I press, I can either scroll down to zoom 6, or I can just type in the number 6, and it will do zoom standard. And what zoom standard is it makes your viewing window from negative 10 to 10 for x and negative 10 to 10 for y. So this is negative 10 this way, positive 10 this way, negative 10 for y, positive 10 for y. So if you want to get on that standard viewing window from negative 10 to 10 for x and negative 10 to 10 for y, you just want to do zoom 6. Okay? So is there anybody whose graph doesn't look like this? Okay? So y equals, and I see that you were missing the plus sign in between there. So we can insert it in there by going second insert plus. And now graph it. Okay, anybody else that has a different graph?
So when I do it, that was pretty quick.
Yeah.
And then I press down.
Okay, let's see. Go to will take us to error. Okay, because remember we talked about the difference between that and that. So this will be a negative sign or
So what did it make?
I did subtraction.
Yeah, what did it
adding
make?
it. So
What did it make?
that's negative. That's going to be a negative sign.
Oh, well, it's not a problem. So that's I know, the one that you showed me.
Okay. Anybody else? Everybody's good? Okay. Make sure you're asking if you're not getting exactly the same thing we are. Okay. So now we have this graph, and we could have created that graph manually by plugging in points just like we did with the previous example. But now that we have the graphing calculator, there's some neat things we can do with it to save us time and to gain accuracy and things like that. So first we're going to evaluate this function at -2. Now I know we could do that by hand, but let's see how we could do it with the graphing calculator. So using the trace mode, that is by pressing the trace button up here on the top row of buttons. When I press trace, it shows me up here what function I'm tracing on, and then down at the bottom, notice that it gives me x coordinate, an x coordinate, and a y coordinate. And if you use the left and right arrows, we can move along this curve. And so you see the bubble bouncing along the curve. It's going to different points on that graph. And so it's recalculating the x and the y coordinate as I move this bubble along the graph. Now we're trying to find the y coordinate when x is -2. So see if you can get to x equals -2. Can anyone land on x equals -2? It gets close, right? But it's hard to land right on -2. I'm at -1.9. And then if I move a little bit more, now it's at -2.1. It's not letting me land right on -2. So what we do, if we want to be at exactly -2, we just type it in. So I type the negative sign, 2, and then enter. And it jumps to that point, so I can see the cursor, the bubble is right there now. And it says when x is -2, y is -9. So now we know the answer to that problem. We know that f of -2 is -9. Okay, now let's, just to see if our calculator is doing it right, let's do it manually. If I plugged in -2 right here, I would have -2 squared plus 2 times -2 minus 1. So what's -2 squared? 4, and there's a negative sign in front of it. And then this would be -4 and -1. So what is -4 minus 4 minus 1? Oops, sorry, it is -9. I changed screens there for some reason. There we go. It is -9. Okay, so what our calculator got is the same thing as what we got when we did it manually. Okay, so now if I want to know what the y value is when x is 3, I just type in 3, enter. I'm still in trace mode. So press 3, enter, and it gives me -4. Okay? And then if I want to go to 9.6, enter. It tells me that is -73.96. Now, I don't see the cursor anymore. Where is it? It's off the screen. My x value is 9.6, so that's over here to the right, but it would be way down here off the screen. But it still calculates it, and it gives us the answer. Okay? So raise your hand if you did not get those numbers, -9, -4, and -73.96 by using the trace feature. Anyone need help getting those 3 answers? Trace worked for everybody? Okay? You have to be on the screen to grab it and trace. Who's calculating this? Is mine? Okay. Let's see. I'm going to reset it. Okay, so so what I showed you there is one method that you can use for evaluating the function for several different x values. Now, -2, we did it by hand. 3 wouldn't be that hard to do by hand, but it would be pretty hard to do 9.6 manually, wouldn't it? Would you want to square 9.6 in your head and then add it to 2 times 9.6? That would be pretty hard to do that. So the calculator is really nice for dealing with decimals and numbers that aren't so friendly. Okay, I'm going to show you another way to do the same exact thing. Okay, and to do this, we need to be back on the home screen. So to get back on the home screen, remember we want to go second quit. So that's second quit, and that brings us back to the home screen. If you have anything on your home screen, just clear it out so you have a blank home screen here. Okay, now you're going to have to follow the steps with me. Okay, so, well, let me back up a second and say this is called function notation. When we do f of a number, that's called function notation. Our calculator does function notation, but the function isn't named f. what is the function named? Does anyone remember when we typed it in? What was the function named? What was it? y1, that's right. If we go to the y equals menu, we see that this function is named y1. So what I really want to do is I want to do y1 of -2. And so the way I do that is back on the home screen. To get y1 to appear on my screen, I have to go to the variables button, which is right here. It says VARS. That's where all the variables are stored. So if I press variables and then look up at the top, we're interested in getting a y variable, so I need to use the menu on the right. So I'm going to right arrow until it says yvars. The first item there says function, that's what I want. And then the first one on the list is y1. So when I do that, it puts y1 on my home screen. And then I want to type in parentheses. So there are parentheses right here on the keyboard. I want to do y1 of -2. And then press enter, and it gives me the answer -9, which is a good thing because that's what we got earlier. Remember right up here when we did it using the trace method, we got -9. Okay? So now see if you can repeat that process. See if you can remember the keystrokes. We started with variables, and see if you can calculate y1 of 3 to get f of 3. Okay? Everyone do that? Raise your hand if you need help with that step. You clear out your function. You have to put that function here. I can do it quickly for you. -x squared plus 2x minus 1. Okay, so now we're on the home screen. And I'm clear your y variables function. So then how do you
So
then whatever. Okay. Some of you are having a hard time using that feature because you cleared out the function. If you go to y equals, our function should still be there. If you erased it, then it doesn't know how to evaluate the function if there's nothing there. So we need to make sure that we still have the function typed in next to y1 in the y equals menu. Okay, yeah, so you don't want to erase the function when you leave. You want to just do a second flip. So retype the function. Was -x squared, -x squared plus 2x minus 1. Okay. When you type that in, you would type in y equals, and you would type it in as -x squared plus 5. The same thing, you would do this, would graph this function, and then if you wanted to evaluate it at certain numbers, you would do the same thing. You could use the trace feature, or you could do the large. So this time I have it under y2, right? So I go second play. Large, x, y large function. Yeah, we're choosing y2. So if I wanted to evaluate that expression, let's say 4. This parentheses 4. But now you can do it in your head. If I plug in 4, I get -18 plus 5. You could clear up y1 and there. Oh, that'd be so awesome. This will graph. Yeah, this function. So y, when you do y1 of 4, it's going to be the top function. This is y2 of 4. All right. So when you put in -3, so we have vars, yvars function y1 of 3. we get -4, same answer we got before. Now I want you guys to watch something. I know you probably already worked ahead and already did 9.6, but I want to show you another trick here. So put your calculators down, put your pencils down, calculators down, pencils down, hands off everything, eyes up here. Okay, so if I'm lazy and I don't want to have to go through all those buttons that I pushed to get Y1 of 9.6 to show up, I already did it twice. So if I just press second enter, what it does is it retypes what I just had on my screen a moment ago. So it retypes the last thing that you typed, and now I can just change this to 9.6. So by pressing second enter, it will retype what you just typed. And then you can change it. Everyone try that. Okay, so second enter will retype what you just got done typing.
How do you get to like the consistency?
Just use your arrows. I'll show you. Okay, so work in your groups now. Actually, I'm going to need to give you a little bit of instruction on how to type this one in, and then you can try the rest of it in your groups. But I'll come around and help you guys also. But for this last example, the function is 3x cubed minus 4x plus 2. So I'm going to go to my y equals menu, and I'm going to clear out that old function. We don't need that one anymore. And when I go to type 3x cubed, last time we did 3x squared, and we got it by pressing this x squared button. But there's not an x cubed button there. So if I have any other exponent, I can use this caret symbol to raise to whatever power I want. So whenever I type that button, I can put in any exponent I want, like x to the third power. On my calculator, it automatically made it a little 3 and it raised it up. But on the older calculators, it's going to look like this. It would say 3x caret 3, and that's okay. That does the same thing. And now I want to, if I have the newer style of calculator like this, I want a right arrow to get back down again, and then minus 4x plus 2. Okay? So everyone go ahead and type that in. If you have the older calculator, it's just going to look like this when you type it in, and that is exactly the same. The caret symbol means raised to whatever number comes after it. Okay? So go ahead and type that in, graph it, sketch your graph, and then evaluate it for those values that are down at the bottom of the page there. Okay? So everyone work on that together right now, and I'll come around and help you if you need it. The graph, by the way, should look like, if you do zoom 6, your graph should look like that.
How do you get out of like?
Right arrow. So if you want to evaluate the function, I showed you two ways to do it. You can either use the trace feature, or you can go back to the home screen and use the Y bars. This is just when I type in whatever number you want. So let's go to and see what it says. Oh, you're saying raised to, and then you didn't put a number after it. Oh, okay. Okay, so we want to raise it to the third power, and then minus 4x plus 2. Yep, that should work now. Okay. Thank you. Is that like It's just another name for the function. And then for the function last function is function G, and another function T of X, and whatever name you want. On the calculator, they're always going to be called Y1, Y2, okay. Right arrow. I think mine takes balance, yeah. You must have been using the trace method, right? Try the other one. Try the y. I need to try using the y1, the bars. See if that looks. Right arrow. Press graph. And then show you two ways to evaluate. You can either use the trace mode, or you can go back to the home screen by doing a second quit and use the bars menu. So if we want to plug in -3 to the trace mode, you just type in -3. Cool. You press graph. Okay, so the problem with the window range says zoom 6. And then zoom 6 will set it back to the standard view window. Okay. Yeah, you have some other stuff after this. We want to just end with the 2. Okay, now so quit and try doing the other method on the home screen.
Yeah, go ahead and do part B, all 3 of these values at the bottom.
Yes.
When I went to 2.5.
Okay, so maybe you can try the other method on the home screen using the bars menu. Using bars, Y bars. Right, so try the other method. Try going to the home screen and use the
Actually, no, I don't.
Y1.
Okay. So once we have the graph and we use the trace mode, trace -3, enter, it tells me that that is -67. And then if I type in 5.1 and press enter, then that is 379.553. So it seems like using this trace mode is really quick and easy, right? But then when you try 12.5, it gives you an error. And we'll talk about why in just a minute. But I did show you another option. If we quit here, I can go back to my home screen and let's see if it works trying the other technique I showed you, which is using vars, yvars, function y1 of 12.5. Okay, that did work. I got an answer. Okay, now does anyone know why it worked here, but it didn't work when we were in trace mode? Okay, Sammy?
Numbers.
Which number is too big?
The Y value.
Okay, well, we got pretty big Y values when we plugged in 5.1, so that's not actually the problem. The problem is, look at our graph. The problem is it's actually the X value that's too big, because what is the domain on this graph? We did zoom 6, right?
Yeah.
Zoom 6 is the standard viewing window, so it only goes up to 10. So we can't plug in any X values bigger than 10, unless we change it. We don't have to use the standard viewing window. Everyone watch up here for a second. Take a look. Owen, watch please. I can change my viewing window. Right now it goes, my X values go from -10 to 10. I can increase that to go from -10 to, let's say, 15. And now when I graph it, see how it moved further over to the right? And now if I use the trace mode, I can type in 12.5 because it's within the domain that I specified in the window, and it gives me the correct answer. So it's not that the Y value was coming out too big, it's that the X value was not in the domain that I had in my window. And so that's where it's nice sometimes to just use the function mode, the Y1, and do it that way. Okay? So in the homework problems that you do tonight, see up there where it says problems 1 through 12 on page 143? Well, when you do problems 1 through 8, you're going to do those by hand. But then when you do 9 through 12, the directions are going to say use your graphing calculator. So you absolutely have to have a graphing calculator at home so that you can do these homework assignments. Okay? So make sure you have your graphing calculators with you every day. And check one out for me if you have not been able to buy one.